Yes, hello and welcome. It's incredible today we're able to see our JAMB reprints. We're able to know where we are supposed to write our exams. We're able to see the time. It's going to enable us the opportunity to, in a better way, structure our time in such a way as to be able to work towards that time and be able to get a better score. So I believe that's what we are doing. I believe we've all done our reprints. Luashe, have you been able to do your reprint?
No, sir.
So what are you waiting for?
I'm waiting for the registration to be fully done before I would do the reprint.
For the what?
Registration to be fully done.
Okay, to be fully done. Okay, you've
Yes,
not
sir.
yet finished your registration.
Yes, sir.
Okay, okay, I understand. So the reprint is already working. Plenty people already. Done their residence. They've already checked theirs, and so so like I was saying, the earlier you checked yours, and you'll be able to know when you're writing, and it will be easier for you to plan once you know the day you're writing. Like I said, most of my students that checked today, they are writing on start on that very 19th. So it's always good you check in time so that you know when you're writing in time, so that you can plan towards that. Very important. So I shared the link for you to check on our group chat. So if you're in our WhatsApp group chat, you see the link. So you can quickly look it up and use it to check when you're supposed to be writing. In that case, by mere looking at it, you know when you're writing. Then, if you now print them out, then because the slip, you also need it during your exams. You need to print the slip and go with the slip to the venue of your exams. So it's important. And like I said before, during the exams, you need to start with those courses that you have comparative advantage on. The subjects that you know very well. If you're doing medical sciences, that should be, say, biology. You check it out first before you go to physics and chemistry, or maybe biology, then English, then physics and chemistry. Because in the end, the aggregate score is what matters. It's not what you scored in the individual courses. It's your total score. You have to attack the problems in such a way that your total score will be okay. Once your total score is okay, then you're good to go. Okay, so we looked at some of these the last time. So I want us to quickly round it up. Since you just have barely 1 week to the exams, So we don't want to be looking at concept per concept say. So we want to be able to look at these concepts from the question point of view and try to answer every question around them. So let's look at this. A resistor with fixed resistance value is called what? Any resistor that is called a resistance box multiplier. So this topic is on our platform solution values. So you can see that the answer to this is already coming out from the explanation. In order for us to understand what standard resistors are, they are actually those resistors that have fixed values. Now they can have values like 1 ohm, 2 ohm, represented with these very and vary. So they don't have like to describe some of these terms used there. Now a rheostat can be used as a potential divider to produce varying potential difference. So use rheostat uh, as a potential divider to produce varying potential difference. A resistance box contains several standard resistors. So now this resistance box we are seeing here is actually a box that contains several standard resistors. So in order to supply resistance. Okay? So with this, we know the definitions of some of these under resistance. And with that, we can simply say that B is the answer, which is standard resistor. So standard resistor is a resistor with fixed resistance. Okay, let's move forward. Now we have which of the following statements is not an advantage of an alkaline accumulator. I would say that there are different sources of voltage. It could be a cell, it could be a battery, it could be an accumulator. So accumulator is an example of a secondary cell. We have secondary, we have primary cells. So the question says, which of the following statements is not an advantage of an alkaline accumulator? Is it A, the electrolyte does not need attention? They're asking for the one that is not an advantage. So if something does not need attention, that means it's an advantage. You don't really need to attend to it that much and it will still deliver for you. B, it can be recharged. Being able to be recharged is an advantage. So it's not, you cannot say that it's not an advantage. It's actually an advantage for a battery to be recharged. That means even when it's used, you don't throw it away, you just recharge it and continue it. So that's an advantage. But the question is looking for the one that is not advantage. It has low internal resistance. Then D, it has a much longer lifespan than the leader. If it has a much longer lifespan, that means it's also an advantage. Okay, so from there, you can easily figure out the one that should be the answer. Okay. But we also need to understand what an alkaline accumulator is to even see whether it does need an electrolyte or not. So the solution says the alkaline accumulator, also known as the nickel ion accumulator, the NIFE. Ni stands for nickel, Fe stands for iron, has positive nickel plates and negative iron plates. The NIFE, nickel accumulator, we call it the alkaline accumulator. So it has the positive plate as nickel and the negative plate as iron, with a solution of potassium hydroxide as the electrolyte. Now, like all secondary cells, it can be recharged. So like all secondary cells, it can actually be recharged. It has low internal resistance. So you can see this option, it has much internal, so that means it can perform well. And very importantly, it has a longer lifespan uh, than the lead acid accumulator. Okay. So the answer there is electrolyte does not need attention. That means in essence, the electrolyte actually needs attention like every other electrolyte. Okay, 39. The diagram illustrates the wire connection to a 3-pin plug. The diagram above, this very diagram here, illustrates the wire connection to a 3-pin plug. The wires P, Q, and R respectively are what? So I want you to name these wires. I want to get to know what those wires stand for. So are they A, life, neutral, and earth? So that means it's P, life, Q, neutral, and R, earth. Or is it B, neutral for P, earth for Q, and life for R? Or is it C, earth for P, life for Q, and earth, another earth for R? Or is it earth for P, neutral for Q, and life for R? What was the actual arrangement? Okay. So this very diagram we have here. So this very diagram we have here, that's what we redrew here, because in redrawing it here, it's clearer. So we have the fuse that is always very close to the live wire, very important. So whenever you see a 3-pin plug, always know that any external thing apart from these 3 wires should be the fuse. And note that the wire that is closest to the fuse, the wire that is closest to the fuse is actually the live. So this R is the live arrangement, should be the one that has R as the live wire. So, and that's what you have here. You can see the fuse here. So this wire that is connected to the fuse is the live wire. Then the wire at the middle is known as the earth. And the first one is the neutral. So if you're going from here, you have neutral, earth, live. If you're going from this side, you have live, earth, neutral. So you see they are coming from here. So it should be neutral, earth, and live. So which option has that? I think that is option B, neutral, earth, live. Neutral, earth, live. Okay. So moving forward, we can have here that a 3-pin plug connects 3 pins. The 3-pin plugs are designed so that electricity can be supplied to electrical appliances safely. This is just the normal plug that you have. If you have your plug, you want to plug it to the main. They normally have 3 plugs like this. It's most likely that one is the live, the middle here is the earth, this one is the neutral. So this is the normal plug you have for your laptop or for any of your appliances. So if you open it up, you see the one that's very close to the fuse. That one is always the live wire. One at the middle is the earth, and the other one is the neutral. Now we don't have only 2 pins. There are some that are 3 pins. If I bring out this my charger. So this is a plug. So you can see the pins. This pin 1, pin 2, pin 3. But you can see this one that is not having any metal. It's likely there's nothing in there. So this is actually in essence a 2-pin plug. Some can be 3. You look at your radio, your TV connector, maybe the plug there is only 2. So that's what we mean by 3-pin, 2-pin blocks. So if you see them, you should know that that's the meaning. It's not something that is so obvious. It's something you use every time. So this is an example here. So for the 2-pin appliances are class 2 electronic device, e.g. TV. So all those electrical appliances that don't draw light much, like your phone, your television, all these new television, they don't draw light. So you can actually use 2-pin for them. For things like very heavy appliances, you have to use like your AC. If you check the pin, you see that it's always a 3-pin. So that's how you know the difference between 2-pin. If you just check what you plug to the wall, that's the pin. So 2-pin appliances they are classified as class 2 electronic device, e.g. for TV, DVD. They operate on low current. That's why they use 2-pin when they operate on very low current, and they do not require earthing. So whenever there is 2-pin, know that the one they took out is the earthing. That means you're just having the live wire and the neutral. So the earthing is not there. Unlike class 3 above, the class 3 is the 3-pin, where there has to be the earthing, which is at the middle. So I also went further to explain what these 3 pins, what they do. So you can see that from a very simple question of asking you the arrangement of the pins, went further to explain a whole lot of things concerning 2-pin and 3-pin so that you're able to understand them. So that's what we're looking at. So for coloring, note that the live wire is always brown. It's always brown. The neutral is always blue. That's how you know the. So that in case if you open it or if you open up the wire and want to see where to connect with one, the brown one is always the live wire. The blue one is always the neutral. Then the yellow, I think the green and yellow stripe is the earth. So the brown wire is held at a voltage of 230 volts, and earth is for becoming light. Okay, so all of them have their functions, and it's good to note those functions. Okay, let's move forward. Okay, we have these. Which of the following statements about parallel plate capacitor is correct? A, capacitance of a capacitor is inversely proportional to the distance between the plates. Okay, that's true. Capacitors can filter AC signals from DC, and capacitors can store charges. So we have A, 1 only, 2, 1 and 2 only, C, 2 and 3 only, D, 1, 2, 3. A capacitor is a device for storing electric charges. The capacitance increase with area between the plates but decrease with the increasing distance. That means it's inversely proportional to the distance. And increase with increases with the electric constant as well. Okay. So this is a typical capacitor where you have the metal plates, the positive and negative one. Then you have the insulator or the dielectric plate in the middle, and this is the distance separating. This is the typical symbol of a capacitor. Some of the uses of the capacitor are that uses of capacitor, radio circuit for turning. You can use capacitor in tuning radio circuits. You can also use it in ignition system for motor vehicles. You can also use it to elimination of sparks when a circuit containing inductance is suddenly open as an induction coil. Okay, so I think the clear answer should be D, 1, 2, and 3. Because the capacitance of a capacitor is inversely proportional to the distance between the plates. It can also store charge. So it must have, any answer must have 1 and 3. I think D has both 1, 2, and 3. That should be the answer. Okay. Of the following statements about magnetic lines of force is not correct. It's not a pass through even non-does, because magnetic lines of force pass through non-magnetic materials. B, they run from the North Pole to the South Pole. Very important. You need to know that that is how the magnetic field lines, that's how they move and tend to be shorter. Set one another, I don't think so. Okay, now let's look at the solution to this. Region or space around the magnet, that region or space around the magnet in which the influence of the magnet can be felt or detected is called the magnetic field. So you have to note that once you keep a magnet like this, there's a region within which anything that is magnetic that you bring close to that region, it will attract it. So that very region that is affecting anything that is moving around it that is a magnet is known as the magnetic field. Now, the effect of the lines of force or pattern or nature of the magnetic field round the bar magnet can be studied by using two methods. You can study them by using ion filings. You can also study them by using what we call magnetic compass needle. So JAMB can also ask you another question under this topic of magnetic field. Which are the two methods that you can use in studying the magnetic field around the magnet, around the bar magnet? So it could be done using ion filings or using magnetic compass needle. Now, when you conduct this study, you're going to note these three things that I'm going to state now that are related to the question that is asked up there. And number one is that they run from the North Pole to the South Pole. You can see that that is already picked. That's option number 2. Run from North Pole to the South Pole. Option number B. So you can see from our explanation, you get both the answer and you learn more things about magnetic field. Okay, that's number one. Number 2, the lines of force do not cross each other. They do not cross each other. That means they don't intersect. So that is making this D that say they intersect one another. That means that it's already a false. So it's already a fallacy, and already you can actually pick that out. You can see that the answer is D here. Intersect one another. So they don't intersect one another actually. They don't cross. And that's what they found out when they conducted this experiment using either the ion filings or magnetic compass needle. You're going to find out the magnetic line of force, they don't cross each other. The lines of force do not cross each other. And finally, the magnetic line of force of a magnet is defined as the line along which a free North Pole end would tend to move if placed in the field. So once you place any magnet in that field, you will see that you will see the path through which the North Pole moves. It will create that line of force that you need. Okay. So tend to move if placed in the field or a line such that the tangent to it at any point give the direction of the field at that point. So that makes option D the answer, as you can see there. Let's move forward. Now, in which of the following activities is the induction coil not useful? So where do we not use induction coil? Which of the following activities is an induction coil not useful? Which of the following activities is the induction coil not useful? Is it A, in investigation of high voltages, Is it B, in the study of electric discharge? Is it C, in the operation of an X-ray tube? Is it D, in AC power transmission? So which of them is an induction coil not used? Now, induction coils are used to provide high voltage for electrical discharges in gases and at low pressure, and as such, they are instrumental in the discovery of the cathode rays and the X-rays in the early 20th century. So you can see this is a prelude into what you can use the induction coil for. So now an induction coil is an electrical device for producing an intermittent source of high voltage. This is done by electromagnetic induction from low voltage DC source, such as battery. So you can use battery to produce a battery is a low voltage DC source. And you can use it to supply intermittent high voltage using an induction coil. So from the foregoing, our answer there is the AC power transmission, because from what I've just read all through, we did not see anything like AC power transmission. But we can see that you can use an induction coil in cathode ray and in X-ray. So this is X-ray here, so that takes care, and you can see that it is used in producing high voltage, takes care of this. And you can also see that it is used for electrical discharge in gases. It's used to provide high voltage for electrical discharge in gases. So study of electrical discharge. So that makes option B the right answer. Okay, we still having much. Wow, still much. Still so much. Okay, some of them we've already looked at. Some of them we've already looked at. Okay, so let's look at these impedance calculation, very important. In a series RLC circuit, where R is 10 ohms, XC is 4 ohms, and XL is 9 ohms. The impedance of the circuit is A 4.1 ohm, B 5.0 ohm, C 10.8 ohm, D 11.2 ohm. So this calculation of impedance, and you're already given resistance, the inductance, and the capacitance. So it's easy for you to just run them through. So impedance Z is the overall opposition. All of them are talking about opposition, but it depends on whether it's in a capacitive circuit, becomes the capacitance, resistive circuit or normal circuit becomes the resistance, inductive circuit becomes the inductance. So well, when you have the three of them in one circuit, then you have to calculate the overall resistance, which is the impedance. Okay. So now XC is equal to 1 over WC, which is this, whereas XL is equal to WL, which is this. So these are the various capacitive and inductance resistance. So Z being the overall impedance is equal to R squared, which is normal resistance squared, plus these other two, both from the resistance from the inductor and from the capacitor. But know that that of the inductor has to come in this form, whereas that of the capacitor has to be 1 over. So check it out. So whatever you get from here, the square, you add it up to this one and square root all of them. The addition, you get the answer. So this can be in this form, this can be in this form. This can be in this form, and this can be in this form. So why I put all these formula, we don't really need them. But the formula is important. You need to understand there are some examples that you'll be giving, then you just be giving the capacitance and the frequency. So you need to now use this formula and sort it out. But here, both the capacitance and the inductance are already given. So you just put them in. 1 is 9, 1 is 1. 9 minus 4 is 5. 5 squared and 10 squared. 10 squared is 100. 5 squared is 25. So we add the two of them. 125. Root of 125 is 11.2. So it's very simple. You can see 4 is given here, 9 is given. So you did not actually use the formulas the way they are here. We just use this last one. So we didn't need all this because the direct values are already given. So we don't need to sort them out again. But it's good that you know that there is a formula like this that exists. And it makes the work very easy for you to sort out. Okay, let's move forward. So this next one, from what we explained about the magnetic field, you can be able to figure this one out. So a student uses two compass needle, and I told you that the two methods of studying the magnetic field by using a compass needle or by using iron filing. So this student in particular is using a compass needle to investigate the magnetic field around a bar magnet, which is actually what it is used for. Now, which of the following diagrams should be the correct direction of the needle? We've already said that the needle must move in a direction. Okay, it's even here. So you see, I repeated the same explanation here. Magnetic field is investigated using these two. It's either iron filing or compass needle. So you see, from answering this, you know the two things that could be used to study the magnetic field. So once you have it, you're going to have movement from the North Pole. You can see it here to the South Pole. That is how it is normally done. You can see this is the North, this is the South. So you can see the needle. It's moving from the North to the South. That's the normal way. If you use iron filing the same way, they are going to arrange in such a way as if they are moving from the North to the South. So any of those, and you can also see in the statement I made here, that it has to be from the North to the South. See this statement here. The lines of force do not cross each other. And it's in such a way that a free North Pole would tend to move. Okay, and they run from North Pole to the South Pole, you can see. So that's why we said in explaining our answers, you're able to better get what the concept is all about. And that's why the option that is right here is option B. Because in option B, you can see the arrow sign saying that it's moving from north to south. See, towards the south, it's entering the south, but towards the north, it's leaving. So it has to move from north to south. That is why this is the answer. This one is moving out from the south, north, and also moving out from the south. So it cannot be the answer. This one is moving into the north. Here is also moving into the south. It cannot be the answer. This one is moving into the north and moving out of the south. Meaning that it's coming out from the south and moving. It's not the answer. So the answer should be the one moving out from the north and entering the south. That makes option B the right answer. Okay. Let's move forward. This one is a little bit lengthy, but let's still look at it. Which of the following particles may be emitted in a process of natural radioactivity? So what and what are emitted during natural radioactivity? Is it alpha particles and beta particles? Is it beta particles and X-rays? Is it beta particles and X-rays? Or is it gamma rays and X-rays? So what and what is emitted during natural? Okay, so let's understand this. So the answer is actually A, alpha and beta particles. But let's understand it better. Natural emission and artificial emission. Now, radioactivity is the spontaneous decay or disintegration of the nucleus of an atom. That's what radioactivity is, of an element, during which it emits alpha, beta, or gamma rays. So there's no X-ray there, or a combination of any of the all three, and also energy. So take note, whenever you're talking about radioactivity, especially natural, there's no X-ray there. So take note. That's my option A. Okay, I'm gonna stop in here. Okay, before I stop, please, it's always good that you know about these. Which of the following reactions has the longest wavelength? Is it gamma ray, wavelength to radio wave, infrared, or X-ray? So the answer is gamma ray. In terms of wavelength, it's gamma ray. And this is the diagram that you can use for that. So I mean, it's radio wave for in terms of wavelength. But when you talk about in terms of frequency, it becomes gamma ray. That's why we have gamma ray here. Whereas here we have radio and TV wave. So in terms of wavelength, it's always radio wave that is the highest, followed by infrared, followed by X-ray, followed by microwave, followed by visible light, and then gamma. But in terms of frequency, you need to know the difference. When they talk about frequency, know that the one with the least frequency is radio wave because it is the one with the highest wavelength. So the one with the least frequency is the one that has the highest wavelength. Whereas the one with the highest frequency has the least wavelength. So like the gamma ray has the least wavelength. You can see it's in the region of 10 to the power minus 14. Whereas this one is in the region of 10 to the power 4. That means it's the highest in terms of wavelength. But in terms of frequency, gamma ray is the highest. Okay. So importantly, we all need to have, like I said before, the reprinting has started. Make sure you've done your reprint. The earlier you do your reprint, the better you know the day you're writing so that you can plan yourselves well. And when you do, you also know the school where you're supposed to write. The school where you're supposed to write is very, very important that you know them in time so that you can prepare. You can start getting to know the place. If it's an area you're not familiar with, you get to know the place better before the exam start. Okay, thank you, and God bless you. We're going to be continuing with our revisions as the exams are going. So, like I said before, okay, not in this class, but if you've not seen your reprint, so I shared the link for you to get the reprint on the on the on the group chat. I also shared this video about the reprint. So this very video about the reprint, okay, it's this video that I shared on the group chat. Once you get there, you see in the description part of the video, you're gonna see how you can print. This is the link. You can also check out this link. This is our latest video on YouTube now. So for those of us watching us from YouTube or from Facebook, you can check out this video. The name of the video is JAMB Reprint, JAMB UTM Examination Slip Print in 2021. Check the description part of the video. This is where they call description part of the video. So you can get other information there. So this is the method you can use in doing the reprint. This is the link. Once you click on this link, you're going to see space for you to put in your either your number or your email, or your registration number or phone number you use in Nigeria. So with any of those, you can see your reprint. So do that and get to know where you're writing, because the earlier you do that, the better. Okay, if there are further information on the exams, we are going to be relating that to you as we move forward. Until your exams, I'm wishing you good luck. Make sure you pray about it. Make sure you've read as much as you're supposed to have read. And make sure that your spirit, soul, everything is together. And when you go to write, like I said, focus on the questions that you know very well. Finish them off first before you start looking at the ones that you're not very sure about. Until then, thank you. See you when I see you. I'm not feeling very fine, so I'm a little bit tired. I think I'm exhausted already. Like, it's been hectic, like getting the lectures prepared and everything. So, but I'll be fine. So thank you. See you when I see you.